In the darkness of the deep Atlantic, beyond the reach of sunlight and far from any coastline, there is a place so strange, so silent, and so beautiful that it has been called a ghost metropolis. No, it's not Atlantis, at least not the one of legend. But in many ways, it is even more extraordinary, because this place, known simply as the Lost City, is not a myth. It exists, and it tells us a story, not of fallen empires, but of Earth's most hidden forces, and perhaps of life's very first spark. It was the year 2000 when scientists aboard a submersible peered into the ocean's gloom and saw something they could scarcely believe. Rising from the seabed, 800 meters below the surface, were vast towers of pale stone. Some small and rounded like toadstools, others stretching nearly 60 meters high, taller than an 18-story building. These structures didn't look natural. They looked sculpted, like the ruins of some forgotten civilization. Silent spires, corridors, pillars. But they weren't made by humans or even by animals. They were the patient, unhurried work of the Earth itself, built over tens of thousands of years. The Lost City is what scientists call a hydrothermal vent field. But it's not just any vent field. It's a unique type, fueled not by volcanic heat, as most deep-sea vents are, but by the slow chemical reaction between seawater and mantle rock deep beneath the seafloor. This reaction, called serpentinization, releases heat, hydrogen, and methane. As this hot, mineral-rich water seeps upward through the crust, it meets the cold seawater. And in that meeting, something remarkable happens. Minerals crystallize and form limestone towers, slowly, year by year, into the ghostly landscape we now see. Unlike the classic black smoker vents, which spew acidic, sulfur-laden fluids in violent jets, the Lost City is calm, alkaline, and ancient. Its waters are warm, around 40 degrees Celsius, and rich in chemistry. They hold the ingredients not only for stone, but for something even more precious: life. Within the chimneys of the Lost City, in tiny mineral pores and crevices, live colonies of microbes. These are not ordinary organisms. They don't need sunlight. They don't rely on photosynthesis. Instead, they feed on gases like hydrogen and methane, transforming raw chemistry into biology. It's a form of life so alien to us, yet so fundamental, that it may resemble the very first life forms that ever existed on our planet. Some scientists believe that this kind of environment, dark, warm, chemically rich, and independent from sunlight, could be the cradle of life on Earth. The towers of the Lost City act like natural reactors, concentrating energy and molecules in a way that may have sparked the first self-replicating systems. And that's not all, because if life can exist here, it might also exist elsewhere. Astrobiologists are deeply interested in the Lost City, because similar conditions may exist beneath the icy shells of Jupiter's moon Europa or Saturn's moon Enceladus. These moons have hidden oceans, warmed from below by their cores. If life exists here on Earth without sunlight, it could also exist there, in total darkness. Even ancient Mars long ago may have had such hydrothermal systems, and with them, perhaps life. What makes the Lost City even more remarkable is its age. Many of its towers have stood for over 120,000 years. It is one of the longest-lived vent systems known on Earth. Located atop an underwater mountain called the Atlantis Massif, a poetic coincidence, the Lost City is made not of volcanic rock, but of ancient mantle stone pushed up through tectonic forces. And yet, for most of human history, no one had ever seen it. Only in recent decades, with advanced submersibles and robotic explorers, have we been able to venture into such depths. Robots like Jason and human-piloted craft like Alvin have filmed the towers, collected their minerals, and sampled the microbial life that thrives inside them. In 2015, a drilling program extracted rock cores over a kilometer long from beneath the lost city, searching for clues about Earth's hidden biosphere. And in 2024, another milestone, the longest core yet, taken from the site to study how life might have begun billions of years ago. Each expedition into the lost city feels like a mission to another planet. But all of this, incredibly, is here on Earth. Yet the lost city is also vulnerable. Recently, a license was granted for deep-sea mining in the surrounding region. This raised alarms among scientists worldwide. The towers are delicate. The microbes are unique. A single mining operation could destroy a system that took millennia to grow. Today, researchers and environmental groups are calling for the lost city to be protected. Not only as a geological wonder, but as a scientific treasure for all humanity. It is humbling to realize how much of our own planet remains unseen. More than 80% of the ocean floor is still unexplored. The lost city is just one example of the wonders hiding in the deep. An alien landscape, not on Mars or Europa, but beneath our own waves. It reminds us that science is still an act of discovery. That there are still secrets, still mysteries, still marvels waiting for us on this planet. And so perhaps the myth of Atlantis was never meant to lead us to a sunken city of stone, but rather to a place like this, a realm where geology and biology meet, where ancient forces quietly shape the future. The lost city may not be Atlantis, but it may be something far more meaningful. A monument not to lost civilizations, but to the origins of life. A whisper in the deep, reminding us where we came from, and where, with care and curiosity, we may one day go.